thank you for the introduction. I'm now trying to get the slides to move. There we go. So Lustre has been around for a long time, but continues to do pretty interesting things. As you can see, the graph, I stole this from Peter Jones. We continue to be, the majority of the systems in the top 10 and the top 100, which is great. There's, as Morris was mentioning, we're getting a lot of interest from machine learning environments, training. And on the one hand, people are like, oh, we need a new flashy, as Peter said, a new flashy file system that's designed for Flash, right? But the truth is that, Lustre is super efficient. I mean, we had to be efficient when computation and storage was not nearly as fast as it is today. And so we do get a boost from accelerating, the hardware, but there has been a lot of work done, by people in the room and people outside the room to make Lustre, able to scale up to, high performance, high IOPS. And that's an ongoing task. I mean, there'll be some presentation later by Patrick Farrell about some of the amazing work that's being done to keep Lustre at the top of the heap. So we can really scale, honestly, I say that the scaling limits for Lustre are mostly defined by people's bank accounts, right? Because we can have, thousands of servers, we can have at least tens, we don't know quite how many MDTs we can have, 60, 100, but more than what people typically need for files, hundreds of billions of files, terabytes, tens of terabytes a second of IO, hundreds of petabytes. I think it's not going to be too far into the future that we see an exabyte single file system. I mean, Oak Ridge is 700 petabytes now. And so it's amazing, to see the continual advancement, and, the demand for this is growing. And I think, one of the areas that we've been focusing on lately is ease of use, because we have the sort of the bells and whistles. We can hit the numbers that people need, but we're getting an increasing market for people who don't know about Lustre. They're not literally rocket scientists running Lustre. And so, a lot of the features that we've been working on lately have been to make it, sort of more out of the box usable, and you get the performance without having to tune everything, right? And while there's lots of tunables, my driving direction to developers on Lustre is that, yes, the tunable needs to be there in case of a case, but you shouldn't have to tune it. It should be like self-tuning, right? And I mean, GPFS did a project like this a few years ago where they tried to remove tunables, try to make it simpler, right? There's less knobs. I mean, less opportunity for things to go wrong. And if the code is smart enough, then it should be able to handle the variety of workloads in a better way. And so, today we can manage the storage, across the whole cluster. In the center is a sort of traditional, HDD OSTs with clients attached to it. But really the paradigm that we're working on is managing all kinds of storage. And, the presentation earlier today from Illinois, having a centralized file system, I mean, that's really saving users a lot of effort, trying to manage their data. And even if the data copying was free, now they have, 3 copies of their data. Which one is the latest, right? I mean, people have the same issue with, their photos on their phone and their laptop and their, desktop and a backup and things like that. You don't want to have to manage this at a petabyte kind of scale. You'd rather have one copy of your data, or it keeps automatically in sync. Is it in flash? Is it in disk? The users shouldn't really have to care about that kind of thing. So having transparent migration and mirroring between the tiers, and, Lustre, it has tiered storage, but it's really hybrid storage because it's not a strict hierarchy of storage, so that you can have the flash and you can have the disk-based storage. But if the data isn't in flash, you don't have to copy it from the disk into another tier just to access it, right? You can read directly from the disk-based storage, and the bandwidth is there. It's only if you're doing high IOPS that you want it to be in the flash. And then going a step beyond that, I think if my mouse shows up here in the bottom corner, like we have persistent client cache, which is actually managing the storage directly on the compute nodes, because NVIDIA with the DGX boxes, they would ship each of the DGX boxes with 8 NVMe drives internally. And if you're attached to a network file system, what do you do with that local storage? Do you make a copy of the data? But then, the problem happens like, oh, is your data set out of date? Oh, we uploaded new training data, but we just spent 1 million, GPU hours training on the old copy of the data set or something like that. And so we actually manage with persistent client cache. You can manage the data transparently on your compute nodes and automatically tier in and out without having to explicitly do data copies. And so that's the sort of overview of the world that we live in today. And I'll talk about, some of the features that are in the upcoming 2.16 release, what we have underway, 2.17, and some of the early proposals for 2.18. I tried to keep things pretty real in terms of what are we actually working on. I mean, there's a little bit of, we would like to work on some of these areas, but I tried not to go too much blue sky and features that, are just a twinkle in some developer's eye, and there's no chance of them ever being done. So, James Simmons was talking about, LNet changes IPv6. So I won't go into a huge amount of detail here, but, this has been an ongoing project. There's been a lot of infrastructure changes needed. And so we're nearly at the end of that development process. And to the large extent, I mean, it's going to be transparent to sites. You'll deploy your new version of Lustre. It'll have IPv6 support. People who are not using IPv6 won't notice anything at all. And then, if you're using IPv6, obviously you'd need some sort of compatibility, but, that's driven by your adoption, right? So the transition is fairly smooth. And as people, evolve into locations where they need IPv6, yes, you'll have to be running the newer version of Lustre, but it will still interoperate with older versions. As James mentioned, there are quite a few places where NIDs are stored in configurations and in RPCs and things like that. They all had to be updated to be able to handle larger addresses, but we made it extensible. So when IPv8 or whatever comes out, you have your intergalactic file system, it will be able to address, every molecule in the universe or something like that. And also some work is being done about making it simpler to manage addressing in general. Having, do DNS name lookups and things like that, so that we don't have to, type out IPv6 NIDs, is a nice thing. It would be, there's still a little bit of work that is needed in this area in terms of, if you have like multi-home DNS records or something like that, you could use that to configure your MGS. So it has, 8 addresses in the DNS database, but you only give it one name and it can find all of the NIDs for you, things like that. So still a little bit of work that needs to be done, but in large part, IPv6 is complete for the 2.16 release. We are, there's a lot of testing that needs to be done. And so it's still, the actual 2.16 release is still a few months out at least, but the development work is done. And so the other area that has had quite a bit of work in 2.16, and it's still ongoing, and I won't unfortunately go into a huge amount of detail because Patrick Farrell will be presenting a whole presentation about this. But I have the slide in because this deck is common to lots of other presentations, but it's just worthwhile to say that, amazing work has been done here. For many years, we were stuck at, Lustre can do about 2 gigabytes a second from a single thread. And we were always like, well, why is that? We tried to optimize these things, and, Patrick dug in deep and figured out it wasn't really our fault. It's the kernel's fault. But, no, I mean, so in this slide, this slide is from 2.15, but, 16 gigabytes a second. I mean, he's gone way beyond that now, and I'll leave the numbers to him. But it's pretty amazing what's being done there, and it keeps us going well for as we get into network speeds that are in the 20 gigabytes a second per interface, and you have 4, 6, 8 interfaces per node. We can handle those kind of speeds, which is great. As I mentioned, ease of use. We have, quite a number of small little improvements here and there that are just, helping it to be more friendly for people who don't use Lustre very often, or, gurus. Sometimes they want to find out things. And so LFS find is one of the things that's visible to people. And I agree, with the HPE sentiment that LFS find is not awesome for, scanning 1 billion files in a file system, or 10 billion, but it's still pretty useful for various things. And we've added in more functionality in terms of, being able to printf various formats. There's more work to be done there, but LFS migrated mirror. On the one hand, the direct IO improvements that I was mentioning for the client IO, we've made the migrate and mirroring much faster, right? Multi gigabytes a second. But on the other hand, in some environments, you don't want to saturate all of the bandwidth on your servers or your clients. And so we put in, through Tim Day from Amazon, put in throttling, so you can limit the speed of the migration, and giving you stats. In the traditional, Unix paradigm, no news is good news, right? But when you're running, migration of terabytes of data, you want a little bit of feedback, right? And so there's a stats option. It will print, every few seconds, it will print a line, how much data transferred, how much, how long it's taken, what's the remaining amount of data, and things like that. A nice feature finding from LANL is LFS find XAdder support. So you can find files with specific XAdders, and so you can tag, for user XAdders if you want. It actually ties in super nicely with another feature that I'll talk on a later slide about, to find files that are created with a specific job, so that you can it gives you a bit of provenance on files, because often, users like, oh, when did these files get created? Who created them? What job run did they have? And so if you tie it in with the job ID, then these jobs were created, in my job submission 1, 2, 3, 4, and then they could look in the output file from that job and see exactly how they got created, which is really nice. Overstriping is a way of putting more than one object onto a single OST, so that you can, avoid some lock contentions. I mean, it's not just in the file system locking, but in not in just the backing file system, exe4 or ZFS locking, but also at the Lustre level. If you have a file that's striped across 1,000 objects, now you get 1,000 DLM locks. And so if you have a very highly contended file, you can actually multiply your Lustre locking resources on that file to get better concurrency on the file. And that makes quite a bit of difference if you have contention. Probably won't apply to most people, but you can attach more than 8,000 devices now to the file system. It's scalable. I think the regression test that we have for it, regularly does 50,000, but it can go higher than that. And most people say, well, why would I need more than 8,000 devices, right? I mean, 8,000 OSTs would be a pretty big file system. But more importantly, what's happening in some of the cloud, virtualization AI market is that Lustre is being mounted in containers, right? Multiple times for a single job. You get like a user mount, you'd get like a data set mount, you'd get, another file system mount for each job that's running on a GPU. And right, there's 8 GPUs, you'd get, 20 or 30 mounts on one file system, on one node. And if the file systems have a few hundred, OSTs each, then you're hitting this limit pretty quickly. And so that's more of a client side issue than just from multiple mounts. And, again, on the client kernel side, there's been a bunch of work. It's nice to see, lots of people chipping in to make Lustre work with basically the, bleeding edge kernels. We're into 6.8, I think, or 6.9, right? So pretty much following, right on the coattails of when the newer kernels get released upstream. And, that makes it easy to use Lustre on pretty much any system. And, there's still more work to be done. One of the things that has been interesting to me for a long time, getting client-side performance stats through StatFS so that user applications could say, when is a good time to do my checkpoint, right? Are the OSTs busy now? Are they, not busy? So we'll have like what is the peak, IOPS and bandwidth of the storage? What is the current IOPS and bandwidth? So it's not like, giving an absolute number of how much my storage should be doing. It's just like in the last hour, like, job load. Am I, are the OSTs busy? And for applications that have some flexibility in terms of when they do a checkpoint, they could, pull this thing every, 5 minutes or whatever, when they're ready at a time step. It's like, if the OSTs are at 30% busy, now's a good time to do a checkpoint, and not when they're at 90% busy, right? And another big client side improvement that we're hoping in the 2.7 timeframe would be erasure coded files. That there was work done a few years ago. It kind of stopped, but it's a feature that we hope to get going again for the 2.7 timeframe, 2.17 once 2.16 is finished. One of the features we are working in internally at Whamcloud DDN is client-side data compression. And so what this allows you to do is, utilize the client-side CPU threads, cores to be doing, running LZ4 or other types of compression to, reduce your data size. Which not just is making your storage more efficient, but with some of the newer compression algorithms, you can basically compress in real time, and it actually would improve your network bandwidth compared to, just sending the uncompressed data. And so we currently have LZO and LZ4. We were looking at gzip. It has some issues with it, but Z standard is next on the line. We'll be investigating Z standard because it's not only has a fast compression mode, but high compression equivalent or better to gzip. And so we're figuring we just won't do gzip out the door, because why introduce a format that we don't, is not the best going forward. But like other Lustre layout features, you'll be able to do, set a default compression level and type for a directory, default. And so it'd be inherited by all of the files in that directory. Or if you need, you can specify per file. If you're really keen, you could specify different compression levels for different parts of a file. If you had a header, let's say in your HDF5 file, you don't want it compressed, but you want all of the data to be compressed, you can do crazy things. But we don't expect people to do that, but the flexibility is there. And so what it does is it chunks up a file into smaller parts, 64K by default, but it can be up to a few megabytes. based on the stripe size and the RPC size. And then it compresses each chunk individually and sends it to the server. And so that allows you to do random IO within a file, and you can do read, modify, write for different parts of the file. Should, you're in the 1% of people who change their files after they're written. But, this gives you quite a bit of flexibility in terms of, having a normal IO pattern without having to decompress, megabytes and megabytes or gigabytes of data, as if you were to, gzip your files manually into one, or bzip, or whatever, the whole file in one chunk. And so when the client is doing the reads, of course, it sucks in whole chunks, 64K of data, and then decompresses it, or, up to 64K will actually receive back. It'll be on the server side, it appears like a file with holes in it, right? So if you try to read 64K of data, you might get 24 or 30K or something like that back. And then it sees that this chunk is compressed. It decompresses it into the 64K of data in memory. And then it keeps it compressed or uncompressed in memory. And in some cases, for better or worse, because of how the client page cache was working, we do have to do some kinds of compression on the server, which has added a little bit of complexity that we didn't quite want initially. But, this might be solvable going forward with newer kernels. But for the time being, we do have to do some work on the server if you have an unusual IO pattern. But you can do things, if you need to, like with tiered storage, for instance, you could have like an uncompressed copy that you're doing for your working load, and it goes into Flash. And then, you when you're staging it into like QLC Flash or something, you would compress it and save the space, right? And so you don't have to do the, work of partial compression if you're doing lots of interleaved IO or something like that. So it's possible to specify compression differently on different copies of a file. And so, it's giving us the numbers we would sort of expect. So we were testing with an HDF5 climate data set, and it's giving you, 2.5 to 3.5 times compression on that data set. In this one, we're looking at gzip. It's quite a bit slower than LZ4, but there's lots of options for, compressibility versus speed. And so this graph, when we were looking, we had some issues with gzip. We started looking into Z standard. And so it's quite interesting. You can see the blue dotted line here is showing for every compression level that gzip has, Z standard is faster and or higher compression. If you look at the ISO at the compression speed, it gives you a higher level. And if you're looking at the compression level, it gives you a higher speed, right? So this is of quite interest to us. On the server side, Morris had mentioned this too. There was a customer that came to us with, they're having weird problems with their file system. And, Luster's been around the block for a while. In the early days, every new system that we deployed was, a project, right? Because we would have new applications, new users, they're doing things. Recently, it's been, pretty smooth sailing in terms of new deployments. It's nothing that even, raises an eyebrow. But we did have this one customer that was, doing something unusual. And we found out this Apache Spark is, and Morris went into the details there. It's very rename intensive. If you look at the stats, every file that's created in the file system has a rename, right? And so, that was unusual. We went 20 years without rename being a performance bottleneck, because we even local disk file systems, ext4 and XFS and things like that, they have one rename lock for the whole file system, right? And we had to work around that. And so, ironically, if you're renaming, on a single client, the client is the bottleneck, but the server can actually rename, thousands of clients concurrently, even in the same directory. everything works pretty smoothly. And, the numbers, I didn't actually post a graph, but we, improved that rename. We created a little benchmark that was doing, simulating that workload. And it's 1,000 times faster, right? And so it, it's nice. It's one of the examples I hold up, why being in charge of your own destiny in terms of Lustre, we control the clients and we control the servers, we control the protocol, and it's all open, and people, we get lots of contributions from different sites. And Peter's graphs show that there's, about 50% of all the contributions in the 2.16 release are from, non-Whamcloud DDN contributors. But because we control both sides of the conversation, we can say, hey, we're just going to change how rename locking works. If you have a client and you have a server, it's mostly server side, but we had the clients, they're talking to a different set of threads on the servers to do the renames now, and they don't block up, other types of file system operations. And, we can realize this optimization, in a few weeks. We don't have to go through a standards body and duke it out for 5 years, right? It's nice that we can have that, faster cycle time. And, another one of the optimizations that's in the pipeline for 2.17 is the write back caching. I don't know if Patrick's talking about this. He's mainly focusing on the IO optimizations on the client, but there are definitely improvements that can be done on the server side as well to allow in-memory aggregation of writes so that when you're submitting them to the storage, right? Lustre has traditionally done almost everything as direct writes to the storage because it's just that much faster to avoid the kernel page cache. And, for large IOs, if you're 8 megs or above, you're blowing out your cache for small files out of the server cache. But now we can do, small write aggregation, and we actually just pick based on the IO size, what type of caching we do. And this allows us to do write aggregation in memory, makes the disk IO much more efficient. And I think Patrick covers some of that. So in terms of other usability improvements, pool spilling was mentioned in the previous Illinois discussion. It allows you to have, like, for a hybrid file system, you can have, a flash pool and a disk pool. You set up a PFL layout, so you're, typically the beginning part, up to, tens of gigabytes potentially, depending on your flash size. You might write a substantial fraction of your data to flash, and then you don't want to blow out your flash, so you say things above 16 gigabytes go straight to disk, right? And you assume if you're writing terabyte size files, you have a semi-sane IO model for your application, right? You don't want to be doing a terabyte of 1K writes, but anyway, so pool spilling allows you to configure, if, your flash pool is getting, 95% full, you don't want your applications to hit, space errors, right? And so it's just a simple, one config line or two config lines to say, oh, if the flash pool is full, start allocating new files directly into the disk pool, right? And it means if you're doing tiered storage with data movement, migration, it means your migrator is not keeping up to the burst. But typically people would rather have their application run slowly but complete than, I've just wasted all of those CPU hours and my file got space, after 1,000 hours of computing. And so, it works a little bit in tandem with the self-extending layouts, in the sense that, this is the catch-all for if self-extending layouts doesn't work, or you didn't configure it for those files or whatever, or you don't know how to use it. This is just the easy out, right? More robust MDT recovery handling, up until I'd say a couple of years ago, as D&E has grown more popular. I mean, we have systems, it's pretty common these days for big systems to have 40 MDTs, right? And, getting those to all recover nicely after a crash was a challenge. And we've been incrementally chipping away at some of the issues that we've seen there. And, it's pretty smooth now. It's definitely not on the top of the radar anymore in terms of what we see at customers, right? So nothing's perfect. And I couldn't even list all of the fixes. That's why it says LU several. Right? If you have the PDF and you click on it, you can see the whole list. But it's we've done quite a bit there to make that just smooth, and so it works. And then people can have failovers, but they don't notice they have failovers, right? Read-only mounting. This is not something that people usually do, but there have been times where people have failing hardware or something like that. They need to bring this file system up and keep it limping along until they can copy it to some other system. And so having it be totally read only, or maybe they can't even mount it read write because of the hardware just keeps on making the file system read only. So you can start off, you can do read only mounting, which is just a nice, nice to have. And, again, because of the changing markets, in terms of where Lustre is being deployed more in, financial services and AI and things like that, being able to dynamically grow, or even in the cloud, right? Being able to dynamically resize your file system, that used to be kind of a one or twice a year or whatever, not maybe 1 or 2 years apart event for a lab, right? But in some customer sites, they want to do this, incrementally every month, right? And so we've done some work to both make this more robust on both the client side and the server side. So if clients suddenly see a file that is referencing an OST that it didn't get told, isn't going to be told about for a second or two, right? They don't just choke. They just say, "Oh, that's an OST that I don't know about. Let me just sit back a minute and, here comes a configuration record," and carry on, right? And on the flip side, you can mount MDTs and OSTs with a new option that says, "I'm a new MDT in an existing file system. Don't start using me yet," right? So that you can bring it up, you can make sure it's working and things like that. And then, enable it, for the crush of users, right? And, we did a file system upgrade recently at a site that added, 20 petabytes of Flash OSTs onto an existing file system. And, they were in use in seconds after they were mounted, right? And so, the file system, the MDSs, they say, "Oh, look, this file system, and for better or worse, it was running at 98% full for, weeks. And as soon as the new OSTs were online, the MDS has an overwhelming urge to allocate files from them. And so, we were up, and then we're like, "Oh, let's do a DF." And it's like, "Oh, there's already, tens of gigabytes on those new OSTs." And so it was like, wow, that's great. And it all, worked very smoothly. Always nice to have. Another nice to have feature that this is more of an administrator kind of, finding the bad user. That's something that comes up quite a bit on the administrative side, like who is pounding on my server, right? And so there's just a really simple utility that one of the developers wrote, LL job stat. And so it's a little bit, it's like top, right? And so it looks at your job stats, assuming you have job stats enabled. And it just gives you, every few seconds, it says who's doing the most RPCs to my file system, right? Who's, doing those 4K IOs, right? And so it's just a very quick thing. It's not intended to be a monitoring tool, right? But it's, it's just a nice to have for those times when you're trying to figure out, who to punish. Obviously, you try to make the file system able to handle every load and every, everything that's thrown at it. right? But the physics of spinning disks means that if somebody's doing something bad, you want to know, right? So I'd mentioned earlier that the storing the job ID into the files. So this was a nice little feature that was developed by somebody at Lanel who, did it as a hackathon project last year during the Lustre Developer Day before the LUG. And essentially, when you create the file, you get the job ID, stores it in Xadder, just sits there doing nothing. But you can query it from, the user space on the client if you need it, or if you're a sysadmin, you want to see, when did this job get created or these files get created? You want some provenance on the file. It's just nice to have. And I said it's semi-automatic provenance because I'm from Canada. We don't allow fully automatic provenance tracking. But of course, yes, you need job IDs enabled. One of the things that's been a long time coming, progressive file layouts. The feature itself was developed in 2.10. And so it's been around a long time. I think it's pretty commonly used. If you're not using PFL, you should. But what we don't do is enable, a PFL layout when you format the file system. And, that's been as much a process issue as it has been a technical issue, because lots and lots, Oleg will be talking tomorrow about testing Lustre, but, we run, 15,000 tests on, every patch that goes into Lustre, right? And a lot of those tests have built-in, biases about how things should work, right? And it's just inevitable. They've worked up until now. And so if you set a PFL layout on the file system, you get hundreds and hundreds of tests that fail because they're expecting, a one stripe file, which has been the default, for Lustre time immemorial. But, PFL is super useful. There's no reason not to use it, but we don't enable it out of the box. And so that's another barrier for people who are new to Lustre, just makes it a little bit harder. So if we enable this, we enabled in, I think it's on the next slide, but we enabled the directory balancing out of the box in 2.15 and in, backported it to Xscaler 6. But enabling PFL out of the box, we just have to go through these, hundreds of tests and see, is this a legitimate failure? Is it a false positive? Is there some assumption in the test on how it's working? Anyways, so it's not a rocket scientist kind of fix. It's just a grinding through all of these tests. But I think it's something that will be great to have. And similarly, back in the day, the machine was king, right? Like the CPU hours on the big compute cluster, were the most important thing to keep going. And if, a user is doing LS on the login node, well, that just has to take second fiddle, right? But the reality is, people time is increasingly, more important than the CPU time, right? And you can see it with, people are writing whatever their HPC codes in Python. And it's like, instead of making my code more efficient, I'm just going to run 1,000 instances of that code and do parallel computation that way, right? Because it's hard to get the people to do these things. And so, to solve a number of issues that we've had with contention on resources, we started using the NRS TBF, and that's the network request scheduler. And it's essentially QoS for RPCs, so that you can balance more effectively the requests coming in to the servers. And, essentially today it's first in, first out. And so whichever job is running on the most nodes, gets the highest fraction of the server resources. But, to help those users that are doing LS or compiling something on a login node or whatever, we started using applying very simple NRS rules on the servers, just to say, in the 99% of the time, there's enough server resources, everybody just gets what they want. But if there are times when there's contention, a job on 1,000 nodes versus LS, we want something out of the box that just makes it, more fair. The user who's just doing a few hundred RPCs, you want those things to complete quickly. The batch job that's using, 1 million RPCs, it can wait a millisecond, right? It's not the end of the world. And so, just to make things a bit more friendly out of the box, right? And it's, again, not rocket scientists, but more focused on making things easier to use. In terms of the low level storage, for LDiskFS, there's still, ongoing work. I mean, we started with LDiskFS, right at the beginning. It was actually, originally ext2, ext3, ext4 is the background, but there's a lot of work being done, outside of Whamcloud, but we're still doing some contributions, in terms of, making things more robust. So E2FSCK fixes, handling large, very large directories. And there was some people, running their adventurous jobs, creating 10 million, 20 million files in one directory. And so, E2FSCK would get bogged down on some of these issues. And so we fixed that. We have done some work, to be able to consolidate the metadata so that when you're mounting, you don't have to do, 10 million seeks to mount this, because file systems, it's hilarious today. So the larger disk-based OSTs are in the, 1 petabyte, 1.5 petabyte range, just because the number of drives is increasing due to declustered RAID to get the rebuild times low. And then the size of the drives are going, 20 plus terabytes each. So to get, 60 or 80 drives into one RAID group, and then, is pushing the OST sizes into multi-petabytes. And so, we've had to keep pace with that on the E2FSCK side. And so, being able to aggregate the metadata to the beginning of the disk means that you can, slurp up all this data, with a few large IOs, as opposed to doing, 8 or 10 million seeks when you mount the file system. So that's a huge deal. I was like, we had some times where, people were just mounting the file system took 10 minutes, right? And so, we fixed those issues. Also, the allocators, the block allocators, searching 10 million groups in a file system took a little while. And so having some of the improvements in the block allocator, right? I mean, we developed MBAlloc originally, but actually Google has been doing a bunch of work in the upstream kernel, and we pulled that back. And it's nice to see actually ext4, on the one hand, it's a bit, it's been around the block as well with Lustre, but it's super highly used in, the cloud world, right? Google, Baidu, all of the big CSPs in China and things like that, they all use ext4 in the backing file system, right? And so it does get pretty a significant amount of attention, optimization, and things like that, and we benefit from all of that. So hybrid, we did some work for hybrid flash and disk in the same OST, so that you can actually just store your LDiskFS metadata on flash and then have the block data on the disk. Persistent trimming support. So for flash, I mean, the honest truth, I mean, more and more of the deployments are flash only. We do still sell, disk-based OSTs, but an increasing fraction is flash only. And so having FS trim being able to do the erase block garbage collection in the background, and being able to persistently manage the trim across mounts, like in ext4, if you run fs trim and then you unmount your file system and mount it again and run fs trim, it's going to retrim the entire device, right? And if as the the Flash OSTs are getting into, hundreds of terabytes as well. That takes an amount of time. It submits, tens of thousands or millions of IO requests to your disk layer. And so you want to be able to do this fast and efficiently. And so we're storing the trim state in the file system as well. And a nice to have, I'm not sure if we'll quite get there, but at some point we did parallelize the first part. That's the slowest part. It was Amdahl's law, right? We took the slowest part of E2FSCK, which was pass 1 and pass 5, and we parallelized those. And they went from 90% of the time spent down to 5%, right? And so now we have to pound the next nail that's highest, right? Which is pass 2 and 3, which is directory entries and names. It's a little bit more complicated because pass 1 was just scanning the inodes. You can do that in parallel. They're trivially parallel. But directory entries, you have to be a little bit smarter. But I think it's doable. And so that would get, we already have the E2FSCK even for the petabyte file systems. It's in the 10 or 20 minute range, right? And for huge, billion file MDTs, again, 10 or 20 minutes, right? But we can get that down further, I think. How am I doing time-wise? I don't know. 8 minutes. Okay. Another interesting area that's very important in cloud environments is data security and containerization. Been lots of work in this area in terms of data isolation. Node maps was mentioned in the Illinois presentation. And it's great to see that this is, I was sitting there, like it's great to see this just as like, it's just a feature that we're using and it works, right? And, this is the sign of a grown-up storage product, right? That you can go into these complex environments. We're doing ID mapping. We're doing different kinds of ID mapping for different clients. We have security. We have, strong security with, Kerberos or shared key. We can positively identify which nodes in a hostile environment are accessing which part of the file system. We can do data encryption of the files at rest. So even the administrators can't, steal the data or whatever you RMA your drive. It doesn't have, secure data on it. And so there's been quite a bit of work to improve node map, role-based admin controls, so even if you have root on your clients, you can prevent root from doing things like changing the quotas or changing, configuration of other settings in the file system, even though if you have root on a client, right? Or we can say, oh, that root user can only do things within the domain of that node map, right? It's quite powerful. One of the next features that's just under development is having a dynamic node maps, so that the original node map genesis was remote sites where you have Indiana University, they had multiple campuses, each one within a different administrative domain, and they wanted to access a central storage system, right? And that's a fairly static configuration, but going forward, people want more dynamic kind of changes, and it's not very efficient to store this in the configuration log, and the config log grows bigger and bigger and bigger. And so being able to have just an in-memory, instantiation of a node map for a job or some temporary blacklist, some clients are misbehaving or something, you want to block them from mounting the file system. And so having a dynamic configuration for node maps is something that's definitely of interest. On the metadata side, I mentioned MDT space balancing. I think this is a really, really big and important usability improvement, right? Even though D&E has been around for 10 plus years, really, we saw lots of times where sites, MDT 0 is full, MDT 1, 2, 3, 4, have 0 user files on them, right? And, we just had to do something about that. And so now, the top levels of your file system are automatically round robined across all of your MDTs. If the space is imbalanced, it will automatically, rebalance them. It doesn't actively move stuff around. That's against my philosophy to actively move data, but it will passively select new allocations, new subdirectories onto the least used MDTs. And so I think that's a really big one. I was mentioning more robust recovery, the job ID stored with the creates, the exclude list, right? So that was the Apache Spark. And so the out of the box exclude list is the underscore temporary, because we know that's a bad actor from Spark. Why wouldn't we put that in there? But it's actually configurable. You can just have a, cat in subdirectories that you don't want to be created. So if you have some workload and it's creating .temp, whatever, you can put that into the exclude list and it will always stay local. I mean, remote directory creation is about 10 times slower than, local directory creation, just because of distributed transaction overhead. But I mean, like I was saying, lots of sites using 40 MDTs or more, and, they're able to get, their 1,000 node jobs pounding on all 40. I wasn't allowed to share a graph that I was sent, but the numbers are, this system was doing 1 million creates, 1 million stats, and 1 million closes per second across, their MDT farm. And, it just chugged along. It's nice to see. Further optimizations there in terms of performance and robustness. And let's see, stat ahead. I talked about this feature previously, but again, it's make the applications work faster without them having to change anything, right? So ls-l and find and any kind of directory traversal, it just runs behind the scenes to make those things faster. And it's not in the version in 2.16, but I think in 2.17 will come up, like for depth first search or breadth first search, it will start to do cross directory stat ahead, so that, like your web browser, preload the first links on the page, right? This is going to preload the first subdirectories, in the tree, so that if you're doing ls-lr or find, it's starting to fetch, especially if you have small directories where you don't really get much chance to stat ahead because there's only, 30 or 40 files in that directory, but it's a deep tree. You can start going down and prefetching attributes for inodes you haven't asked for yet. This was actually a very interesting presentation at IO 500 last year at this one is ISC 23, so I guess that's a year ago. But just showing how, all of these small incremental changes have really improved performance. Like the hardware is not exactly uniform going forward, but the hardware improvements were not nearly equivalent to the aggregate performance improvements that we've seen across these different versions. And a lot of the work has been done, the stat ahead, the IO improvements, and those are ongoing things that you need to do to keep up with what is available from the hardware. And just because the hardware is getting faster doesn't mean that your code can keep up with that, right? And so we do the optimizations in the code, and it really showed. I mean, these are aggregate scores. So, I mean, the IO, if you don't know IO 500, but the bandwidth is not just the hero bandwidth, right? It's not the IOR with large IO size. Bandwidth score includes, the hard IO phase where you're doing 47K interleaved writes from multiple clients concurrently, all in the same file, right? And so that, all of those improvements go in here. Same with the IOPS, that's metadata, includes, 1,000 threads, creating files, 3K files in a single directory, right? And so these are legitimate hard scores that applications will see. This is a little bit, metadata write-back cache is one of the features that's under development. I wouldn't quite say it's feature complete, but it's functional, and there's a huge patch series. It will need some work to get it landed into 2.17, but it's a great feature. It does you can create a whole new directory tree only in RAM on the client, and then it flushes it to the MDS in the background, right? And so you can get I have slides on the next 100 times speed up for certain workloads. It's not for every workload, but for UNTAR or genomics, machine learning, where you're extracting some data and then processing on it and then deleting it or whatever afterward. It's definitely a huge improvement, and it's still fully POSIX compliant, so you don't have to sacrifice how your application semantics are working. Through the DLM locking, it will ensure that any other clients accessing that namespace, it will be flushed to the server before they're granted access. So it's totally transparent to the applications, but it's a huge improvement. Erasure coding files. That's a long-standing wish list for Lustre, but in 2.17, that work is going to start and pick up from what was done a couple of years ago. That code was, I would say, like 50 to 60% functionally complete. It does need some kind of infrastructure improvements and things, but I try to stage development in a incremental benefits type of model. So you're not waiting 3 or 4 years for some huge miraculous feature to appear. You get 10% functionality gain on every step along the way. And the other big development project that we have is metadata redundancy. And again, this one is staged in terms of an incremental improvement, right? So there's a lot of services that live only on MDT0, right? In terms of quota, FLOC, the FID lookup database, and those are things that can be incrementally moved or replicated to other MDTs to improve reliability. Improving the transaction performance is something, like I was saying, remote make deers are 10 times slower, right? I think with some improvements, we could improve that quite a bit. And so those are all building blocks for being able to do, replicating the root directory across, 4 or whatever MDTs, so that you can still access the file system even when MDT0 is offline. And then, it will work its way down through the tree to be able to, you'll be able to configure, this is a high availability directory, people's home directories, you want those to be, fairly robust. This is a scratch job. It doesn't need to be robust. Maybe every 24th checkpoint you do would go into a mirror directory. There's always going to be a performance trade-off. Nothing is for free. So you want to be able to select that. And either if it's a user or the administrator, you can tune that on a per directory basis. And, that will be, it's 2.18 plus, but we'll, get some incremental improvements along the way. And my last slide. So, people always say, oh, they want to get rid of POSIX, or, what can we do beyond POSIX, right? And Lustre has grown up with POSIX, right? So people think, oh, do we need a new file system? My opinion is that, POSIX is the standard. People have been developing applications for POSIX for decades, right? There's a huge investment in that interface. And even if there's other file systems, that are, providing some new interfaces, they all have to provide POSIX anyways, because you can't rewrite every application for each new file system that comes out, right? It's just infeasible to do that. And so, but I totally agree that POSIX doesn't do everything that people want. And so there's lots of extensions already that people, maybe they're not familiar with Linux, the Linux kernel adds extensions, that are just system calls in Linux, and they don't have any formal standard approval, but, fallocate or FiMap or all of these things which are extended on. And I think those are great. We support all of those things. AIO and IOU ring for asynchronous IO is really a new paradigm for accessing your storage, as long as it doesn't break all of the other applications and tools that you've developed that are also trying to interact with that data. And, on the flip side, if you say, oh, we're going to implement a subset of POSIX, which subset is it? Because even after 20 years, there's crazy use cases that applications do. It's like, oh, I have an ACL on a file that I don't own. Am I allowed to delete the XADDR on that file? And it's like, if you haven't even got the basics of POSIX down, you're not going to get that right either. And so, to be usable across a broad range of applications, and it might be fine. You wrote a new application and it's using HDFS, but where's HDFS now, right? It's kind of an also ran, because every new generation of developers develops their own, IO interface, and now you're stuck with whatever was cool 10 years ago, right? And so I think, POSIX is just going to continue to be the de facto standard, and you can go outside of POSIX. You can have, translators to and from POSIX, NFS and SMB and S3. But I think that, it's going to be the lingua franca, going forward, is like, Fortran. Whatever the language is 10 years from now, it will be called Fortran. Not quite, but anyway, thank you for listening. I don't know if I have time to...
Andreas, thank you. Do we have any questions for Andreas this afternoon?
Aurélien de Grémont, NVIDIA. I'm wondering, why is it against your philosophy to move that automatically?
I think, well, two reasons. I think one is that that takes away performance from the applications that could be running, right? The file system doesn't know, what is important data to move, what's not important data to move, right? It can't make a good decision on when is a good time to start all of this bulk movement. And so my philosophy would be that that's something you can do, like in some file systems where they have automatic purging and things like that, data is, rolling off every 30 days off of the file system. And when you delete old files, 100% of those deletions are from the old OSTs that were existing before. And if you have imbalanced OSTs, then, your new allocations will preferably go to the new ones. The deletions will almost always come from the old OSTs. It rebalances itself over 30 days anyways. And if you're spending, half of your IO bandwidth to fill up the new OSTs, you're probably moving old files. You're not using those ones for the new IO anyways. If you really want to do that, you can, but I don't think that that's the file system's job to do that. But I mean, there are tools, and we have tools at DDN that will automatically rebalance for you. If you're doing tiering storage, I think that's different because you're going from one class of storage to another class of storage, right? The flash to disk, and you can specify a policy, but I don't think it's the file system's job to enact a policy, right? But I think we provide lots of mechanism to do that, right? And so we should make it easy to do that if you want to do it. And I think there's probably gaps there, but I don't think we should do it ourselves. But might be convinced otherwise. Anyways, other questions?
So you talked about, I think right at the beginning of the talk, you talked about some commands for like identifying users using like LL-stat, I think is one of the commands.
LL job stat?
Yeah, LL job stat. And is there like some idea of taking that and using it as a way to throttle users and stuff based on access?
The LL job stat is it's a sort of a post facto. It can give you real time information about who's currently abusing the file system. The bottom line here, the NRS TBF rules, that's how you would throttle users, right? You can, very simple NRS rules. Basically, it says, everybody gets 5,000 RPCs per second, right? And so if you set that up and a job is not using all of that capacity, but if say you got 100 jobs and they each get 5,000 RPCs per second, if your system can't provide that, it's going to proportionately scale it down until it can satisfy the number of RPCs per second that it can actually provide. And so what will happen then is the bad job will get throttled into the, let's say it can do 300 RPCs per second for all of those 100 jobs. And the bad job will be capped at 300. The user jobs will get their 50 per second or whatever they're doing with LS. And so they won't notice any throttling at all. And the bad job will be capped at 300 until all of the other jobs that are waiting will get all of their RPC serviced, and then it will go up to the 5,000 again. And that might, will be dynamically handled, every second, right? And so I think that that's far superior to saying that job should be penalized and having an active system that is trying to find which job is the bad one right now and saying that one's bad, I'm going to throttle it. It's just better to write a generic rule that does it automatically for you.
If we have no other questions, thank you very, very much, Andreas.